All right, so yesterday on the video that y'all ended up having to watch, we talked about this problem with the IQs being matched because we thought there was such a big difference in people's intelligence, you know, that was going to be a big thing that we should control, and so we matched. So I wanted to talk to you about that because then we got to thinking about it this morning with somebody else and was wondering this. If you have half of the people go sit quietly, take a test, and then go listen to Mozart and take a test, okay? And so then you're going to compare the difference between those two things. And then what do the other half of the people do? What order do they do that in? They'll do Mozart, and take a test, and then they'll do nothing and take a test. So let's think about that. If they do Mozart and take a test, and then they go sit quietly and take a test, if Mozart effect is really making you smarter, those people who listen to the Mozart first, aren't they kind of already smarter for the second half? So, so anyway, maybe a way to remedy that is to do it a week later or something. I don't know. But I think because of that, that is why somebody in my third period pointed out to me that the instructions say for it to be completely randomized. Dun, dun, dun. I like having smart students because then when I do something wrong, they point it out to me and then I can fix it. So let's talk about, upon you doing it completely randomized, I'll let you check the matched here in a moment, but upon it being completely randomized, let's talk about what that would be. That would mean you start with your 125 college students and they go in a bag and you randomly assign them by putting them all in the bag, shake well, pull out 63 of them, because you can't do half to 125 or whatever, to the Mozart environment, and the other 62 to the sit quietly environment. So you literally, the students only do one environment, okay, and then they take that test. So how do you handle measuring their improvement if they're taking that test after just one environment? How can you handle that? How can you have an improvement or a difference?
Just take it first.
Yes, they had to take it first. So imagine this. 125 college students, they all take a test. That way, that's their baseline. Then you put them in a bag, randomly assign them to, half of them do the Mozart, half of them do the nothing, and they take a test again. And then you see if there is a difference in their test scores, if there is an improvement, if there is a change in their test scores. So you're comparing, you're going to get the average of all of the Mozart groups improvement, and then the average of all of the sit quietly group, and compare those to each other. Okay, that's how you would do completely randomized, which was actually what it asked for. So let me give you a few minutes to read your neighbors, because here's what you need to look for. All right, when you're reading your neighbors, look for two things. Does it include all the steps that it's supposed to? And have they clearly communicated it to you? You need to, I need to hear you say, what do you mean here, if you can't tell what they mean? Because that's one of the things we're learning, is how to clearly communicate what you're trying to say and what you're doing. Okay, so let's take about 3 or 4 minutes and take a look at your neighbors. Okay, so the idea is that I want you guys checking each other's out instead of me just talking you through it, because it is an important skill to be able to read other people's writings and talk about that. Okay, so this number 2. This one talked about control the confounding variable of type of stroke. So it specifically is referencing one item to control. One item to control implies just a straight blocking. Bunches and bunches of things to control, that's when you need to do matched, okay? So bunches and bunches of things to control, that's when you're matching. One item to control is just plain blocking. All right, so in this case, we did plain blocking. So this should have been a Babrat me cap. Make sure that your person blocked, because, and so on and so forth. Okay, so let me come around and see how you did on that. Did anybody want to do matching on this or try to do matching? Do you want to have that discussion? Okay, let me just let you take a few moments and go over this with your, read your partners, this one, and I'll leave it up here for you to check while you check your partners. So this morning I had a discussion with somebody in tutorials because her natural inclination was to say, hey, I want to block and have a person like be his or her own block, and they do the new and the old, and then we compare their swim time to themselves. Okay, I get that. And honestly, I'm afraid that we might just be so enamored with the amount of control that matching gives us that we're wanting to just make every experiment a matching situation. And they don't intend on that to be done on AP exam, okay? So we need to really take clues. For example, this pretty much said we want to control this confounding variable of type of stroke, period, not all of the other characteristics of the swimmers. So one single blocking, not matching. Okay, now, so here's what. Listen up, we are then we go to a block, so we say we're in the backstroke block. We are then relying on randomness to do what? So I'm in the backstrokes, I got them all in a bag, I'm shaking them well. What am I relying on randomness to do?
Reduce bias.
Reduce bias, how? Randomly assign half to the new swimsuit and half to the old swimsuit, but what about the qualities and the traits of those people in the new and the current, those two treatment groups? What?
So you're randomizing the traits?
Okay, when I am counting on randomness to spread all those unknown traits evenly to the treatment groups. When you need to spread unknown traits evenly, randomize, randomize. So I blocked by front stroke and I blocked by backstroke. And then in the backstroke, I am relying on randomness to give all the, in one block, I've got a good mixture of fast and slow swimmers. And the other one, I've got a good mixture of fast and slow swimmers. So I relied on randomness to distribute those traits evenly to the treatment groups, okay? All right, moving forward. Here comes this next one. This was the warm-up, which you are quizzing on Monday. And so we're going to skip this first thing about statistically significant, but this is such an interesting situation where they have done a study and they realized that there was a higher risk of death on the weekend than those that went to the emergency room on the weekdays. Okay, so what do you have to say about that?
People do crazy stuff on the weekends.
Okay, thank you. People do crazy stuff on the weekends. I guess what I'm also asking is, does this say that you going on a weekend causes you to die at a higher rate? No. Okay, so they're trying to imply that, but that's not what it is. And plus, what kind of a study is this? Observational study or experiment? Okay, being an observational study, you can't claim a cause and effect relationship. Okay, so no cause, just a correlation. So here's what I have on the part B. If you think you're quite ill on Saturday, should you wait until Monday because you're afraid that your weekend care is going to be so sucky that it's going to risk you dying?
No.
Okay, no. The study does not prove that the weekend care is worse than the weekday care. What is this? What's happening? We got a lurking variable going on. More activities, more risky behavior on the weekends, all that kind of stuff is what making that a higher, not worse care. Yes, ma'am.
I still think the hospital could be understaffed on the weekends.
Okay, true. Good. It could be understaffed on the weekends also. Very good. Not enough, not a good ratio. Yes.
Severity of injury also go into it?
Yeah, I think the severity of injury probably is playing into the risky behavior, making the more severe ones, and so then, yeah. Okay, very good. All right, so next. Subjects of this second one are the overweight dogs kept as pets. Explanatory variables were diet and exercise. So let me ask you this. How many factors The question is, how many things does a dog get assigned to it?
4.
2.
But yeah.
A dog gets a diet plan and an exercise plan. So that's 2 factors. Now, in the diet factor, how many levels? 2, A and B. In the exercise factor, how many levels? 1 and 2. Okay, so for a total of 4 treatment groups. Now, the response, I had to go back up into this problem and really carefully look at it because it was like a scavenger hunt trying to find the wording for exactly what they're going to measure. And so I finally found exactly what they're going to measure right here. They are doing this experiment to help their chubby dogs lose weight. That is why I knew the response I am measuring is their weight loss. Okay? Yes.
Would improvement in dog weight also work?
Probably. Improvement of dog weight, yes.
What about average weight loss?
No. Good question. Average weight loss is a wrong answer because when I say response, that's meaning per dog. What are you finding out about that dog? That dog, I'm getting a weight loss, not an average. I get the average at the end, and that's what I compare. Okay?
Yeah.
I've seen AP mark off for that little thing there. Yes, ma'am.
Can you describe, can you define an explanatory variable? Is that just what
And
the treatment?
Explanatory variable is pretty much those treatments that you are checking to see if they are creating an effect. Yes, ma'am. Okay, hey, I realized whenever we were talking about, in another class, and we were talking about the homework you're going to have, people didn't know what experimental units are. So guess what? Another name for experimental units is the subjects. So maybe write that there. Experimental units. That's just another way of saying subjects. The subjects are experimental units. Okay? All right. Moving on. Oh, I've lost my pictures that I had. I had a backhoe and a forklift over here to the side all ready to pull up and show you, and I can't find them.
Oh, I saw them.
They were on there? Okay, so hold on. Re-put them in here. Okay, so let's take a look. Looky here. You know what that is? No, that's a backhoe. Okay, and then come over here.
Oh.
See that? What's that?
That's a forklift.
That's a forklift. Okay, so do you think the wear and the rigorousness that these 2 machines do is the same? No. We definitely are going to have more wear and tear on which type of machinery? The backhoe. So we do not, we're afraid that if we rely on a big bag, we might get too many backhoes in a group that is for the additive, and then it won't be able to see if the additive's working or not because they just looks really sucky because the backhoe is getting repaired quickly. So that means we need to control that type of thing. So if we're controlling it, then what type of experimental design does that mean we have? Blocking. So here we go. So they told me that I have 20 machines available to me, so I picked 10 backhoes and 10 forklifts. I don't think there's a right or wrong answer there, but I just was like, I'm testing both of them, so might as well do half and half. So then I start my Babrat Me cap. Okay, so my Babrat Me cap. So read your persons. I blocked by backhoes and forklifts because the rigorousness of the type of machine may affect the number of hours the machine runs before it needs repair. Okay? And it's pretty straightforward. So let me give you a few moments to read your persons, see if they included everything. Okay, go. So you have a quiz on Monday, and it is like what you have here on the warm-up. Tuesday, I'm going to give you back your quizzes and tests, and we're going to go over all the review and stuff. But let me go ahead and kind of talk to you through your homework this weekend, and you're going to have some time to get started on it. So go to page 49. 49 is the start of the unit review. On page 49, there are 4 free response questions, and then look after that. starting on page 50 is the multiple choice, because your exam will have multiple choice and free response, okay? So this weekend, or tonight, well, not tonight, but this weekend, you're going to be having the free response part, so just page 49 now. And then Monday night, so if you know you're really busy Monday night and you're not going to be able to do the rest of it, you could do the rest of it this weekend as well. But Monday night, you will be doing the remainder of the review, 50 to 53. Which is all the multiple choice. So that Tuesday, it's done. And that is worth 2 stamps, by the way, the 49 and then 50 to 53. And so Tuesday we come in here, we go over quizzes, we go over the review in class, and then you test on Wednesday. All right, let's talk about this page 49. So here we go. Number 1. Which of 2 brands of laundry, brand A or brand B, cleans clothes better? Okay, so that right there is giving you an indication of, at least I know the response, and an explanatory variable. Does one brand work better in both hot and cold water? So we want to design an experiment to find out those things. A basket containing 120 pieces of dirty laundry is available. So you are asked questions A and B. Now let me ask you this. On part C, describe how you would randomize your design. What is that asking you to describe? That's when it asks you how to randomize, specifically, it's asking you to tell the big bag story. Okay? But I'm going to add something to this because we are just so awesome. I want you to, it says design an experiment to find out. So I want to make sure that you include your design paragraph. So on another piece of paper, you're going to have to probably write the answers to this because you will have a design paragraph for this story. Okay. Moving on to the next one, because I have something actually I need to kind of give you a heads up on the next one. How many of you have gone to the doctor's office and you've seen the nurse practitioner or the physician's assistant instead of the doctor, him or herself? Yes, a lot of us. That happens now that we're busy and all that kind of stuff. We're seeing for some simple things that. So this number 2 is posing the question, is a nurse practitioner giving the same quality of care as the doctor when it comes to asthma, diabetes, and high blood pressure patients, okay? So here we go, number 2. Nurse practitioners are nurses with advanced qualifications who often act much like primary care physicians. An experiment assigned 1,316 patients who had no regular source of medical care to either a doctor. Please mark out that number right there. I think the way that they have these numbers here and how they're uneven and everything just really kind of baffles me on how they did this experiment. Or a nurse practitioner. Take that number away. So we're not going to specify who got how many patients. All the patients have been diagnosed with asthma, diabetes, or high blood pressure. So let me tell you something. We do not want the nurse practitioner to get all the easy cases, or the doctor to get all the easy cases, or the hard cases, or whatever. We need to control these distribution of these cases. So I want you to control the distribution of these types of cases. So I'm not going to tell you what that means, but that's my tip, something I want to tell you. Okay. The response variable, so what you will be measuring is the patient's health and their satisfaction with their medical care after 6 months, okay, on a scale or whatever. So is this completely randomized design, block design? So you'll say that. And who are the experimental units? What did I just say to you earlier are the experimental units?
Subjects.
Good. And how should they be randomized? So that means tell me the big bag story. But I also want you to, on this one, include a design paragraph for this one as well. Okay? All right, and numbers 3 and 4, you can just answer the questions that it poses. You do not have to include a design paragraph on 3 and 4. So I'm just adding that design component on numbers 1 and 2. Okay, so those 4 problems are your homework this weekend.